Hey there, pre-algebra students. We are now moving on to inequalities. So inequalities are our mathematical sentences that don't have equal signs. They have inequality symbols. And we'll look at, here's an example right there, less than. We also graph the solution to an inequality. So we'll be solving them and graphing them. Let's start with why we learn inequalities. Inequalities are a practical math concept. This is the way we talk about the world. So inequalities generally describe our world. At least 30 kids were at the party. That means it could equal 30, the number of kids at the party, but that more than likely it was more than that, or we could say it was more than or equal to. And this is an inequality that would represent this phrase right here for at least 30 kids at the party. There could have been 30 or there could have been more. And this is saying that the unknown value k could be equal to 30 or it could be more than 30. So 30 will work here, 31, 32, 33, 34, 35, 36, 37. All of those numbers will work here. But if you instead go on to numbers below 30, 29 will not work. If there were at least 30 kids at the party, then 29 kids would not work. It doesn't make sense. You can pay up to 20 days late. So you could pay up to, that means the number of days you could pay was up to 20. That means it could be equal to 20 or it should be less than 20. The maximum occupancy, that's another one. The number of people has to be no more than 200. No more than 200, so the maximum occupancy. So that's the way we talk about the world, is with inequalities, and we can use them to describe our world too. So as we stated, an inequality is a mathematical sentence where the solution is a range of values rather than a single or fixed value. Each of these symbols has a name, and we're going to go ahead and put in those names. This first one is a less than. You name it for what's on the left-hand side of the symbol. No more alligator mouth talk. All right? This is a greater than, because again, we name it for what's on the left-hand side. This one is called less than or equal to. Less than or equal to. And this one's called greater than or equal to. So the less than or equal to and greater than or equal to are a little bit counterintuitive. Like, how can something be both? Well, it's not both. It's or. It's either less than or equal to. So you can say at most, and that would use that symbol. You can say at least, and it would use this symbol over here, at most and at least. You graph an inequality solution. So an inequality graph has two parts, the circle and the direction of shading. Well, it should say 3 parts. An inequality graph really has 3 parts. A number line, a circle, and a direction of shading. So what we're doing is we're showing the solution set of x is greater than or equal to -7. So x is greater than or equal to -7. So that means that we have a number line. So we're going to draw a number line. We're going to put 3 little notches on our number line. Put the number in question in the inequality in the middle. Make the left hand 1 less and the right hand 1 more. Be careful, as I just did, when you're graphing with a negative, that you make sure you count down to the left and up to the right. Think about how your negatives work. Now what we're doing is showing the solution set for this particular inequality. So x can equal -7. So we're going to put a closed circle on top of the -7, and then we're going to shade in the direction of values that are greater than -7. And I make it look like this, and fill in the arrow so you can tell that we're shading. So this represents all the values that fit this inequality. Any value that fits this inequality should be on the circle and in the shaded region. And all of these are indeed bigger than -7. For this one, we start the same way. We still have -7 in the center, 1 less is -8, 1 more is -6. Again, we have a circle. In this case, our circle is on the -7. And then, because we're talking about values that are smaller than -7, and this time we shade to the left to show values that are smaller than -7. The open circle indicates that we start at -7, but we don't include -7, because -7 doesn't make this true. Let's think about that real quick. Is negative 7 less than negative 7? Well, no, of course not. They're equal. So you have an open circle over here when you have just less than or just greater than. You have a closed circle when you have an or equal to symbol. To solve an inequality, you're going to solve just like you would an equation. Instead of using the solution to check your inequality, you're going to use a number that's from the solution set, and we'll look at that with a few examples. When you multiply or divide both sides of an inequality by a negative, you must flip the inequality symbol. Guys, this right here is what we're all going to mess up the most. So I need you to make a mental note right now to be with me, be paying the attention, and let's talk about this little tidbit here one more time. It says when you multiply or divide both sides of an inequality by a negative, you have to flip the inequality symbol around. Let's talk about why that is, and then we'll do some examples. Think 1 is less than 2. True, right? Of course it is. 1 is smaller than 2. Well, multiply them both by negative 1, and look what you get. Is negative 1 smaller than negative 2? Well, on my number line, if this is 0, and here's negative 1 and here's negative 2, no. Negative 1 is further to the right compared to negative 2, which means it's bigger. So this is wrong now. It should be negative 1 is greater than negative 2. So again, as it says, when you multiply or divide both sides by a negative, you got to flip the symbol. Now, I may not have shown that, but how do you switch the sign of something? Why do you switch the sign of a variable or number? You multiply by negative 1. So that's what I did here, and clearly this was no longer true. We had to flip the symbol around. So that's going to be something important to remember as we work on solving. All right, solve the one-step inequalities, then graph the solution set. So starting with number 1. Number 1, we have x plus 15 is greater than 8. Pretend that's an equal sign right there, and treat it like it's an equal sign. Subtracting the same number from both sides, the inequality will still be true. And you'll notice that I just put on my, bring down my symbol instead of bringing down an equal sign. So my solution for this first one is x is greater than negative 7, which is almost identical to what we graphed on the previous problem, or the previous slide. So I know I have my negative 7, negative 8 on the left, negative 6 on the right. I have an open circle, and it's shading up. And I can check my solution using an answer that was in my solution set. Use negative 6. Negative 6 plus 5 is positive 9, which is greater than 8. So I know I got it right. Let's do the next one. Negative 6n is greater than or equal to 24. Divide both sides by negative 6. Now I should recognize here that I just divided by a negative. That means I need to flip the symbol around. And hopefully you recognize that in the process of checking your solution. So next I'm going to go ahead and check it. Well, I should probably check it before I graph it. So let's check it first. Let's use a value that's smaller than. So we need a value that is smaller than negative 4. Let's use negative 5. This time I'll write it out so we can see it. Negative 6 times negative 5. Is that greater than or equal to 24? Well, I get 30 is greater than or equal to 24. Yes. So I'm pretty sure I did that right. Put in your 3 notches. Put your negative 4 in the center. Negative 5 is 1 less. Negative 3 is 1 more. Closed circle on negative 4, shaded downward. Hopefully you're getting the hang of this. Let's do another one. 11 is less than d minus 15. Well, I don't like that. I want it the other way. I want the d minus 15 on the left-hand side, and I'm going to put the symbol on the other side. And if you notice, the d minus 15 was on the larger side of the inequality, and it still is when I rewrite it here. So it was on the larger, still on the larger side. So when I flip-flop the two sides of an inequality, I got to flip that symbol around as well. So again, this is one where we're going to use our properties of equality. I'm going to add 15 to each side, leaving me d is greater than 26. Pick a number. Let's do 30. 30 minus 15 is greater than 11. Yep. I know I got it right. Graph. Number line. 26 in the middle. Aren't you glad you don't have to count all the way down to 0? because you don't. 25 below, 27 above. D is greater than 26. Open circle, shaded up. Last one on this page. Y is divided by 7 is less than or equal to 2. Well, it's got division in it. We're going to solve it by multiplying. Y is less than or equal to negative 14. All right, so let's pick a number. But I'm going to be smart about this. I'm not going to pick negative 15 because that's not divisible by 7. I'm going to pick negative 21 because I want smaller than negative 14. So let's check negative 21. I'm completely out of space. Whoop. Negative 21 over 7, is that less than or equal to negative 2? Is negative 3 less than or equal to negative 2? Yes, it is. So on my number line, I am again going to have 3 notches with negative 14 in the center. It's going to be a closed circle, shaded down. Can't number my number line because it got too tight there at the bottom of the screen. 2 multi-step ones and we'll be done. Okay. Couple of multi-step inequalities. The big difference between them is that one's going to need the symbol flipped around because we're going to have to divide by a negative, and the other one isn't. So let's go ahead and try solving these. All right, so let's go with this one. We're going to add 5 to each side of this one because we're undoing our addition or subtraction first. Nothing has changed. 3x is less than or equal to 30. We divide both sides by 3. X is less than or equal to 10. So on our inequality graph, we put 9, 10, 11. Closed circle, shaded down. Now I just had to re-record a section of this because I made a mistake. Notice here, that it's, the numbering is 9, then 10, then 11. Now don't get confused because we were numbering with negatives before. No matter what, a number line is always numbered increasing to the right. So 9, then 10, then 11. If it was negative 10, it would have been negative 11, negative 10, negative 9, because that's still counting up. All right. And how about this one? This time, again, we're going to start by adding 5 to each side. So that part is the same. Negative 3x is less than or equal to 30. Now I'm dividing both sides by a negative 3. A negative 3, which means I've got to flip my symbol around. And we described that earlier. If you don't remember, go back and rewatch. We end up with x is greater than or equal to negative 10. So actually, like we just talked about, I'll put in the rest of my number line. It's going to be a closed circle, shading up. Shading up. And that, my friends, finishes off inequalities for us. So we're not going to solve super difficult ones, but we are going to need to solve inequalities nonetheless. Make sure that you understood. Jot some questions down in the margin if you need to, and I'll see you guys in class.